Well, welcome to grade 12 math. This is the Applied 40 course, first lesson. This first unit is probably one of the best math lessons or units you're going to have in school. Maybe one of the best units in the entire subject, of any subject. And the reason for that is the entire unit is about making money. How do you earn money through interest and investments and things like that. All right, the first lesson is on simple interest. Before we start that, I have a bunch of definitions for you, and you should become familiar with this language. So read through this. You don't have to memorize the definitions, but you should understand if I start talking about a mutual fund, what am I talking about? Okay, for the most part, these are not the focus of the course, but they are all places where you can gain interest on your money. What is interest? That's kind of the focus of this unit. Interest is the amount of money earned on an investment. In other words, if you have money and you invest it, you can invest it in many different things, and there's some of them listed here. But if you invest it, how much are you paid for that? Okay? Like if you think about a bank, the bank's the most common place to invest money. If you give them some of your money, let's say you have $100 and you want to put it into the bank, they are going to pay you interest because they are using your money for their own investments. On the other hand, if you want to borrow money from the bank, say $100, you're going to have to pay the bank to use that money. Interest is sort of like the payment that is being received for the use of that money. Okay, this unit talks about how do we get interest, how do we collect interest. Okay, and the first type is simple interest. That's today's lesson. Simple interest is the amount of interest earned on an investment or paid on a loan based on the original amount and the simple interest rate. Okay, let's take a look at a couple of things here. Language, you need to again know what these words mean. Term is how long is it the investment. The interest is how much the percent that you're going to be given in terms of paid out. Principal is the original amount. Maturity is when is the loan or the investment over, or when is the end. The future value is what is it going to be worth at the end of the investment. And rate of return is the ratio of money earned or lost on the investment relative to the amount of money invested. Okay, we'll go over those. Some things you should know about investments. These three: liquidity, risk, and yield. Liquidity means how easy is it to convert your investment to cash. Sometimes when you invest money, you can't get it back until the end of the term. Sometimes, for example, if you put it in a basic savings account, you can go and take it out anytime you want. Okay, so how liquid is your investment? Risk, there are investments that if you put the money in, you may never get it back. On the other hand, you have a chance for higher interest rates if you do that. Okay, the more the risk, the more the potential yield. The yield is how much you're going to get back. Okay, couple of things here. You know, you're probably familiar with the savings account. That's just leaving money in the bank. A GIC or a term deposit you're going to put in, but usually you can't access it until the term is over. So you might invest money for a period of 2 years and you can only get it back after 2 years. Usually you get a little bit higher interest rate for those. Okay, you can see some of the other ones here, things that you could invest in. We'll talk about some of those throughout the unit. So let's talk first of all about simple interest. This is the formula, and you are allowed to write that on your cheat sheet because you are allowed a cheat sheet for tests and exams. What does it mean? Well, the I is the interest rate. The P is the principal, or what are you starting with? How much are we investing? The rate is the interest. The interest rate. And T is how long or the time that you're going to have the investment in. Now there's a couple of things as we go through these questions that you need to know about those, and you'll see this one. You'll see in this example. So what is the future value of his investment? Okay, if we try to figure out if you invest $2,500 in a GIC at 2.5% interest, paid annually, this means once a year for 10 years. So let's try this. I equals, the principal is $2,500 Okay. The interest rate. Now, when you use this formula, you don't use 2.5%. 2.5% means 2.5 out of 100. That's what percent is. So that's going to be a decimal. And how long? Time is usually in years, so there's no problem. We can just put 10 there. Okay, and if we put this into the calculator, all right, you should get used to your calculator. We end up with $625. That's the interest. That's how much money you would be paid if you invested that much money. That is not the future value. The future value would be the original amount plus how much you get for interest. Okay, so you can see that your money in those 10 years has grown from $2,500 to $3,125. That's simple interest. Okay, use Marty's investment to write an algebraic expression that could be used to determine the future value of any investment. Okay, I don't think you're going to use a formula like this. I think you're going to do this, but we can write that out as a formula. What it is going to be is principal plus interest. Okay, and another way we could write this is instead of putting interest there, we know that interest is PRT. Okay, and so sometimes you're going to see this. Don't panic about this. If I factor out the P, you're going to see this formula. Okay, and future value, a lot of times we use the letter A. Means the same thing. Okay, how would an interest rate of 3.5% change the future value of the investment? What do you think is going to happen if the interest rate was 3.5 instead of 2.5? Okay, well, let's see how much the interest would be. So we would still have the same amount of money, $2,500, but now we would have 3.5 over 100 times 10. And this would give us $875. So if it asks us how would the interest rate of 3.5 change it, well, the future value would be greater, so we can say that. Future value would be greater. How much greater? Well, 875 is how much bigger than 625? It's $250. So it'll be $250 more. Okay, this is a common sort of slant in the applied course, is that it's not going to ask you just to kind of generate some numbers. It's always going to ask you to kind of think about them and make a statement about your answer. Be prepared to always finish off the answer. This one says, how would the interest rate at 3.5% change the future value? It doesn't say what is the new interest rate. It says what has happened if you do that. How is that interest rate going to be different? So you always have to answer that. Okay? Let's try another example. So Suni invests $15,000 in a savings account, earns simple interest. Okay, got to read things like that. Simple interest, 8% paid semi-annually. This means twice a year. And she intends to hold the investment for 4.5 years, when she will withdraw the money to buy a car. Determine the value of investments at each half year. So this is, we're going to be asked to do this a whole bunch of times, this simple interest. Okay, so at year 0, she's got $15,000. What we're supposed to do now is, after half a year, how much is she going to have? Okay, so let's see how much interest we would be earning in these periods. So the principal amount is $1,500, the rate is 8%, and the time is half a year. Okay, we're supposed to do this every half year. So I equals 15,000 times 0.08 times half. All right, let's calculate that. So you're going to get $600 is how much interest you would be making every 6 months. So if we add 600 here, the value is now going to be 15,600. And since it's simple interest, this amount is going to be the same every time. We're going to keep adding 600. So this would be 16,200. This would be 16,800. After 2 years, it would be 17,400. 2.5 years, it would be 18,000. After 3 years, 18,600. 3.5, it would be 19,200. And then we're going to have 4 and 4.5. So we're just going to add $600 each time. Okay. Verify using the formula principal plus the interest. Well, that's what we did here. We just added 600 each time. Okay. Let's use a graph here. This might be interesting to you. If we put time on the bottom and we put, what the value of the investment is, all right, what do you think this graph is going to look like? Okay, if we go up every half here, what's going to happen to these dots? Okay, I think I'll just cut some of the graph out here, and let's start at 15,000. All right, and let's go up by 600. That'll make it easy. 15,600, 16,200, etc. And then I think what you're going to see here is you're going to get a graph that just goes up by 600 every half year. And if you remember back to grade 10, this is going to be a linear function, right? It's going to be a straight line. It's going to go up 600 each time. Okay, the y-intercept is 15,000. That's what we start with. And the slope is $600 each time. So this equation would be 600x plus 15,000. Do you remember this? What was b? B was the y-intercept. That's where we start the graph. Okay. Oh, I made a bit of a mistake there. That's not where I started the graph. 15,000 would be what it is, 0. Yeah, that's better. Sorry for that confusion. So the graph looks like that. So the y-intercept's 15,000, and this is the slope, 600. It's going up by $600 every payment period, I guess. Just going to back up there for a second. Let's write some of this stuff down. So my y-intercept was 1,500, and my slope is how much it's going up every period. But we were actually going up a half a year, so it was going up $600 every half year. So actually our slope isn't 600, it's actually 1,200. Okay, so I made a mistake there. I apologize for that. I gotta just change that. Okay, now I'm not going to ask you to make an equation like this. I'm not going to ask you to graph this like this. What was the reason for showing you this? The point is, with simple interest, it's going to increase by the same amount every time. Okay, every year you're going to get the same interest payment. It doesn't change. That's important to understand with simple interest. Okay, we'll talk more about that in the next unit when we talk about compound interest, because that's much better. All right, let's do a few more questions here. Ingrid invested her summer earnings, $5,000 at simple interest, paid annually. She intends to use the money in a few years to take a holiday with a friend. How long will it take to get $8,000? Okay. If she needs to get $8,000, how much does she have to earn? She needs $8,000. She starts with $5,000. It means she needs to earn $3,000. This has to be how much she makes in interest. Okay, so let's try to put that into our formula. So the interest earned is going to be $3,000, and she's starting with $5,000, and she's earning 8%. Remember, to get the rate, you always take the 8% divided by 100. The question is, how long does it take? We don't know the time this time. Do you know how to isolate for t? Okay, let's do a little bit of math here. This is going back, wow, I don't know how long ago. When did you learn to do algebra? Grade 7? So what we're going to do here is we're going to multiply 5,000 times 0.08. I believe that's going to be 40. Let's just check that with a calculator. 5,000 times 0.08, 400. Good thing I checked. 400 t, and then if I want t by itself, I'm going to divide by 400. So 3,000 divided by 400. Okay, let's divide by 400. T is 7.5. Now what is 7.5? 7.5 is 7.5 years it would take for us to gain that much interest. Here's the problem. You're only collecting that interest at the end of every year. You don't get it in the middle of the year, so there's no way we would have the amount of money at 7.5 years. What we actually have to say is it would take 8 years. Okay? And that's not that I'm rounding off from 7.5. Even if that said 7.1 years, I still need the full year to collect the interest, so it would be 8 years. Okay? Alright, here's something new, and this can be on your cheat sheet too. Your rate of return, the formula for that is interest, so how much you make in interest, over what the original principal is. And you're going to multiply that by 100. Why do you multiply by 100? Well, the reason we multiply by 100 is that is going to give us our answer in a percent. So, what is the rate of return? Well, 3,000 is how much interest we had. What is the principal? It was 5,000, and we're going to multiply that by 100. Okay, so this is going to be 60%. Alright, so last question here. Grant invests 25,000 and he ends up with 29,375. By the way, how much interest did he earn then? That would be 29,375, take away 25,000. So interest is 4,375. So the question is, how long, no, it's 5 years, what interest rate did he get to get this kind of interest? So let's use our formula. The interest is 4,375. The principal was 25,000. I don't know what the rate is, but I know it's invested for 5 years. So let's do a little bit of math here. Algebra, we'll multiply 25,000 times 5. And then we'll divide by 125,000. So 4,375 divided by 125,000. And the rate is .035. Okay, now it says what interest rate is that? How do we change 0.035 to interest? Well, we just multiply by 100. So this is 3.5%. Okay, Grant cashed in his bond after 4.5 years because a house he had been admiring came up for sale and he needed a down payment. How much money did he have for the down payment? Yeah, this is interesting. Okay, so if you would have left it in for 5 years, you would have made 29,375. If you put it in for 4.5 years, you only collect 4 years of interest. because it's simple interest. Okay, so let's figure out how much the interest is here. 25,000 times 0.035 times 4. So that you can just put that all in the calculator exactly like you see it. And the interest is 3,500. So how much money did he have? He would have had 25,000 plus 3,500 equals 28,500 for the down payment. Okay, so you can see all these questions, they always have a little bit of a twist to them. They always ask you to find out a little something that's, not quite as obvious. Okay, it's not just finding the interest. It's not just how much is the interest rate. It's always, okay, well, now that you know the interest, how much do you have for the down payment? Always a little bit of thinking involved. Okay, so homework is here. You can begin on that, and I will go over that with you in class.